Hello, good morning everyone. So today we are continue with a series of learning HyperMesh new interface. You can use both HyperMesh 2023 or 2024 right now. So today I will show you how to set up the tensile test using the HyperMesh. But in this case we are using the LSDYNA solver for this. So here is modern. You can okay. Here is our modem, but you should keep in mind that we need to choose a solver interface LSDYNA here. Okay, so here's our problem. It's a material. Young modulars are power ratio parameter here, and we use a U strength 250 megapascal and E tans values 1000s. We fix on the left hand side, and we using the end force displacement 10 millimeters in 1 second. Okay, so how to set up right now in HyperMesh, I will show you. So here is a model with basic information, tab component element nodes. Now I create a material. Okay, so I choose this. I use a MAT 24. Right, it's very common material, steel material in HyperMesh in LSDYNA. So I choose here is a steel. And the row, okay, maybe row. I choose density, right? So density 7.85 E minus 9. Okay, young modulus 210,000 megapascal. Ratios maybe 29. Okay, 6 Y, yes, U stretch here, it has 1000. Okay, and next we will create the section cell, I mean the property of this shell element. So I choose this property and choose a D3 millimeters. So I choose here element form is Hughes Liu, and 1 is default. Number of integration point, maybe I choose 3, and here I choose 2, and the most important parameter thickness here T1, you just choose here 3. So I double click on the component, we'll jump to the component tab browser, so you can manage all the component here with this tab. So I choose property 3 meters, material steel. So this is almost done for set up the material property for this specimen, the tensile specimen. That's the next step. We need to make the constraint and define the loading. So before that, we need to create a set for which we constrain where we apply the load. So I choose set here. Okay, I can change to set type is the node, right? You can see the solver keyword is a set node list here. And then I just choose this left hand side. The name set, maybe I choose fixed node, and I just click here and drag the mouse here to confirm this. So I already create the first set. You can double click set to go to the set browser management. You can right click to duplicate this one. Maybe I choose this as move. No, not right. So here I can unselect this guy. I select this again, and I confirm here. So you can right click here to review how you select, okay, to check again. So we create a set already, and now I create the constraints. I go to the analyze, you choose boundary constraint here, so you can select this guy. Okay, 6 degrees of freedom, and I choose this fixed one, right, and then finish. And then I can create another one, is but I remove, I make the freedom in X direction. I release this direction. I choose this second one is a move node. Okay, so when you go to the modern browser, you will see it have a load here. You can double click the boundary PC here. You can right click here to review how you select this guy, 6 degrees of freedom. Yeah. You can click on this guy. We already remove here. You can update if you want here. So finish the fix. So now we need to create the curve to define the load curve, right? So I can go to the modern and choose curve here. you can get a plus icon, and then you can double click to change the name. Maybe displacement this. Okay, so I choose here is 0 0 is a ram force, right? So I choose here is 1. Okay, so now I need to create the enforced displacement. So how to do this? I think there are another way you can do this using a SOLVER browser to set up for different kind of SOLVER, different keywords. So that's SOLVER here. You can right click to create a boundary here. I choose this boundaries pre-described motion like displacement here. Okay, so I just choose the class is a move node, and I can choose a DOF translation X. I choose a curve load here already defined, and yeah, the most important SF is a scale factor, so I choose 10 because we apply the 10 millimeters. Okay, so that's the rest parameter we can keep the default. So now we already have finished the boundary condition, the material property, and the last thing you need to create a termination time, right? So you can you can view to show the entity editor, or you turn on turn off this. Okay, solver I can create here. I just control the termination here, so you can choose the termination here. Okay, termination time here you can choose end time which we want, but we have another way to do this using the TCL script, and then you can no need to do manually again setting a thing. I have the LSDYNA script to can help you to quickly this. Okay, I choose termination time here, maybe 1, and database binary plots. I choose DT here, or you can number of animation you want, but here I choose. You can choose here's 100 if you want. Okay, and then the DT time to check out the plot the curve. Maybe I choose 1 here. Maybe I don't need this guy. Yeah. Okay, I create. After I create, this system automatically makes a control termination for you. You can modify it manually. Yeah, depend what you want. Yeah, the GL starts, the mask, sum here. You also can choose here. Okay, so after setting this, you can go to the validate tab to check again any issue with the modem. I run the check. So there are no any error or warning message. This is modern. It's good and ready to run. So you can go to the file and export. Okay, so you can export the tensile test complete .key, right? And then you can run, and actually we can check again with the notepad, and you can using Ctrl F to find each keyword termination time. You can modify if you want. Okay, so after we run, we can show it in the, we can do both the pre and post in new HyperMesh. So I just right click here, I choose this one, I change this guy to HyperView client. Okay, so I can open. So I choose this D3 plot and apply. Okay, so you can maximize this guy for easier to see. I can change this guy. Sorry. Or you go to this to see which suitable for you. Okay, so I go to the contour to see the displacement, whatever. So I apply here to see the displacement. Click here to make an animation, and also you can stop here, come back, and you can change this to stretch. Okay, hold my stretch, apply. You can choose averaging methods here, apply, and let's see. Or you can click one by one, yeah, step by step, to see how it's happened. You go to the last one like this. You also can see effective static string as well. Okay, you want to show the element, you can choose here to show the mesh line here, or you also can create the curve, the load, whatever, using the hyper graph here. But for this model, I don't need to do that. Okay, so that's all for my demonstration how to use HyperMesh to set up the LSDYNA solver. Thank you very much for the watching. See you again. Bye.